Alright, Computation Practice 2. Convert the following into correct scientific notation. That's actually optional. Directions. Convert the following ages of events into dates on our model calendar. The Earth itself is 4.5 billion years old. If we compress the history of the Earth into one calendar year, when would the modern humans appear? Assuming right now is midnight, December 31st. So here's our scale, our actual versus our model, and it gives us that the first modern humans came in 200,000 years ago. So starting with that as our given, 200,000 years real over 1, then incorporate our scale for every 4.5 billion years. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. Okay. Real years is equal to 1 model year. And we know that 1 year has 365 days. Cross off years, real, year. Leaves us one multiplication on the top. 200,000 times 365, and then divide that number by the 4.5 billion. 1, 2, 3, 4, 5, 6. That would give us 0.0162 days. Well, that's awfully small. So let's convert that day into hours and minutes. 1 day equals 24 hours, and 1 hour equals 60 minutes. Hours cross off hours, days cross off days, and take that number times 24 and then times by 60 equals, the only unit left was 23.36 minutes. So how many days before New Year? Perhaps we should change that to the time. Since it is 23 minutes before midnight, that would mean it is sometime after 11:30, so 60 minutes in an hour. So it would be 11:37 and change. 11:37 p.m. The last 3 minutes of the day for modern humans. Next question. Convert the following sizes to the scale indicated. Mr. Colacinski's globe in the front of the room is 37 centimeters across. The real Earth is this many kilometers, 12,756. How far away would the moon be at this scale at 384,000 kilometers? So that's our given, the 384,000 kilometers over 1. That's real. And our scale says that the 12,756 real km, because of our Earth, is going to be 37 centimeters in our model. So real km crosses off, that leaves us with centimeters. Just kind of estimating, it looks like that's probably going to be a pretty big number, so I'm going to go ahead and bump this up to meters. 100 centimeters into 1 meter. Let's see how that goes. we've got 384,000 times 37, and then that number divided by 12,756 equals, and divided by 100 equals. So that's going to equal to 11.13 meters. So if that globe at the front of the room was our actual scale, the moon would be somewhere out in the hallway 11.13 meters away. Oh, I forgot to cross off my centimeters. Well, meters. Alright, looks good. Moving to the next one. These are conversions. Mr. Kolsinski drives 7.6 miles to work each day. It takes him 25 minutes. What is his average speed in meters per second? So this is a speed, distance over time. 7.6 miles over 25 minutes. So there's two ways to attack this. First, we need to get rid of the miles and turn it into meters, and then we need to get rid of the minutes and turn it into seconds, because that's our desired unit, meters per second. To get rid of the miles into the metric, we can use this one. 1 mile equals 1.61 kilometers. 1 mile is equal to 1.61 kilometers. And then it's not on here, but hopefully you should know by now that 1,000 meters, 1,000 meters, and we need the 1 km at the bottom to cross that off. So miles cross off miles, kilometers cross off kilometers. Leaves us meter at the top, which is what we want. Now we attack the minutes. Since we have a minute at the bottom, I need to put a minute at the top, and I know that for every 1 minute, we have 60 seconds, so that kills the minutes, leaves us with meters over seconds. Just need to do the math. Here's 7.6 times 1.61 times 1,000. So that's our number on the top. I'm going to divide it by the numbers on the bottom. First divided by 25. And then divided by 60. So those are the two numbers at the bottom. That gives me, on average, 8.157 meters per second. Alright, looks good. So, a can of soda weighs 370 grams, period. An elevator with maximum lift capacity of 2 tons. That's what we are dealing with. How many cans of soda can it safely lift? Alright, so the given here, since this is per can, 370 grams, that's a ratio. This is our only single unit, 2 tons. And we know that we're trying to find cans as our answer, so cans must be at the top. 1 can is equal to 370 grams. So now we need to get rid of tons and grams because we want the answer in cans. So let's look at what we have unit-wise. We've got a ton that's equal to 2,000 pounds. That's the only place ton exists, so ton at the top. So we need 1 ton at the bottom, which means 2,000 pounds. Tons cross off. So pounds and grams. So pounds and kilograms, we've got 2.2 pounds per 1 kilogram. Kills the pounds. We have grams and kilograms. Kill that off. We need every 1,000 grams is equal to 1 kilogram. Kilograms top, bottom, grams top, bottom. No more units except for can, which is what our answer is supposed to be in. So now let's figure out how many cans this elevator can hold. It's got 2 times 2,000 times 1,000. That's the number on the top divided by the numbers by the bottom, 370 and 2.2. 2.2. So this elevator can hold 4,914 cans at its maximum weight. That's a good case of diabetes there. Yep, everything checks out. Last one. The fastest marathon run in the world, Dennis Kimeto of Kenya, ran the 42-kilometer Berlin Marathon in 2 hours and 33 minutes. And the distance from here to Kalamazoo, downtown to downtown, is 2.42 miles. We want to know how long. So that's a time. So we know time has to be on top. So if we start with our distance, 24.2 miles over 1. We've got a speed of every 42 kilometers. Distance has to go on the bottom because we need the time on the top, is 2 hours and 3 minutes. So we've got 2 units. A couple ways to deal with this. You can either convert this into a decimal of an hour. That's too much like math. I know that 2 hours has 60 minutes, so 60 times 2 would be 120 plus that 3. I know that's going to be 123 minutes. And so we just need to kind of kill off our duplicate distance units, and the conversion for miles to kilometers is here for every 1 mile at the bottom, because we have a mile at the top. It is 1.61 kilometers. Miles cross off miles, kilometers cross off kilometers, and we're left with minutes as a unit. And that looks like fairly reasonable numbers to deal with, so I don't think I need to convert to any other units. Multiply the top numbers, 24.2 times 123 times 1.61, enter, divided by 42 at the bottom. That means 114.1 minute. And if I were to try to get that into an hour, since that's doing too much work, let's see, minus 60. So it's 1 hour 54.13 minutes. Almost 2 hours to run from here, downtown Battle Creek, from downtown Kalamazoo. All right, hopefully this helps.